30 kilometers below you, a floor of ammonia, cloud the color of old parchment, stretches across a horizon 4 times farther away than any horizon on Earth. There is no ground beneath those clouds. There will be no ground beneath anything ever again. Welcome to Jupiter. Jupiter is the largest planet in the solar system, wide enough to line up 11 Earths across its face, and heavy enough to outweigh every other planet combined twice over. We have watched its clouds through telescopes for 4 centuries, though from this far, you'd never know it spins faster than any other planet. A full day here lasts under 10 hours, and that furious rotation whips the clouds into its iconic racing stripes. Yet almost everything beneath that top deck of cloud is still mathematics and inference. Only one machine has ever gone inside, and it lived for less than an hour. In the next few minutes, you will go far deeper, through the cloud country, past the greatest storm we have ever known, down to where hydrogen becomes liquid metal and where down itself stops meaning anything at all. Begin where the sunlight still reaches. The clouds you are falling toward are ammonia ice, crystals of the same compound in household cleaner, frozen at 145 degrees below zero. Up here, the air is thin and stained in bands: cream, rust, umber. The sunlight is weak, a 25th of Earth's, a permanent late winter afternoon. The soup of colors painted like Van Gogh himself. Sulfur compounds, phosphorus, sun-cooked hydrocarbons. The colors of the most photographed planet in the sky remain, chemically speaking, an unresolved mystery. Fall for 10 minutes and the parchment floor becomes a ceiling. Beneath the ammonia lies a second deck, ammonium hydrosulfide, the browns and coppers. Beneath that, at pressures a few times Earth's, drift clouds of ordinary water, the same substance as the mist over a kettle. And in between, Jupiter does something we only discovered when the Juno spacecraft caught it glowing on the night side. Lightning, this high up. It should be impossible. Lightning needs liquid water, and up here, water should be locked solid. The answer is ammonia, working as antifreeze. It melts the ice into slush. The slush charges the clouds, and the flashes bloom where no flash should live. The same chemistry builds hailstones unlike anything on Earth. 2 parts water, 1 part ammonia, slush wrapped in ice. Scientists call them mush balls. Each one is an elevator, kidnapping ammonia from the high decks and carrying it down into the deep, hidden atmosphere. Storm by storm, the planet swallows its own weather. South of the equator, the cloud lanes bend around something enormous. The Great Red Spot has been watched by human beings for nearly 200 years without interruption. And if a spot sketched by astronomers in 1665 is the same storm, it was already old when Isaac Newton was working out gravity. It is a hurricane with no coastline to ever make landfall on, and so it simply does not stop. Hold your position at its edge. The winds passing you exceed 400 kilometers per hour, fast enough to cross Manhattan end to end in 3 minutes, sustained not for hours, but for centuries. And yet the vortex is so vast that from here it looks nearly still, a coil of rust and salmon turning with the patience of a thing that has outlived every nation on Earth. A century ago, it could have held 3 Earths side by side. Today, just one, because it is shrinking and no one yet knows toward what. Even its color negotiates with time. Some decades brick red, some decades pale salmon, once nearly white. For most of history, we could only see the storm's face. Then Juno flew directly over it, and the storm's mass tugged on the spacecraft. A pull measured through the wobble in a radio signal. The verdict: the Great Red Spot's roots reach 300 kilometers down. That sounds bottomless. It is actually the shallow part. The jet streams that feed it, the banded winds themselves, go down 3,000 kilometers before the deep planet finally smothers them. Everything below this point is a mystery. Only one object built by human beings has ever been. In December 1995, a probe the size of a laundry basket, released by NASA's Galileo spacecraft, struck this atmosphere at 47.8 kilometers per second. It remains the fastest atmospheric entry any machine has ever survived. In 2 minutes, it braked so hard that it weighed more than 200 times its Earth weight behind a heat shield burning at 16,000 degrees, hotter than the surface of the sun. Then the violence ended, a parachute opened, and the probe simply hung there, drifting down through the amber light. Its instruments woke one by one. Thermometers, wind sensors, a light meter squinting for cloud droplets, while distant lightning crackled as static in its radio. It tasted the wind and found it strengthening with depth. Proof the weather is not a thin skin. It sniffed the chemistry and found less water than anyone predicted, because by pure chance it had fallen into one of Jupiter's rare clear patches, a desert between clouds. And it noticed something quietly strange, a detail that seemed almost trivial. Neon, which should have been abundant, was nearly missing. 1 part in 10 of what the sun's recipe promised. For 57 minutes and 36 seconds, it spoke. And everything it sent home, every reading humanity has ever taken from inside the largest planet, amounted to 3.5 megabits, less data than a single photograph on your phone. 160 kilometers below its entry point, at 22 times Earth's air pressure and 150 degrees, the transmitter finally failed mid-sentence. Below the clouds, the light gives out entirely, and the descent changes character. The pressure doesn't crush you at a boundary. There is no boundary. The hydrogen around you simply thickens towards something like a haze. 10,000 kilometers down, a journey as wide as the Earth. The pressure passes 1 million Earth's atmospheres and the temperature 5,000 degrees. And here, hydrogen, the simplest thing there is, gives up being a gas, a liquid, anything familiar, and becomes a shining metallic sea. Stirred by the planet's rapid spin, is a dynamo. It generates the strongest magnetic field of any planet in the solar system, an invisible structure so large that, if your eyes could see it, it would dwarf the full moon in Earth's sky. Its tail streams away from the sun so far it brushes the orbit of Saturn. And it is, in the end, intense weather from a metallic sea. And inside that metal sea, it's raining. Helium refuses to mix with metallic hydrogen, like oil shrugging out of water. So it gathers into droplets and falls, and dissolved inside every falling drop. Neon. The missing neon. The clue a dying probe radioed upward in 1995 was the shadow of weather no one will ever see. It is, right now, raining out of Jupiter's sky beneath the clouds. Deeper still, Juno's gravity data suggests the core is not a neat ball of rock, but something stranger. Diffuse, partly dissolved into the planet, like sugar half stirred into tea. Jupiter is fuzzy at the center, and down here the planet runs hotter than the surface of the sun. Heat left over from its own formation, still leaking out after 4.5 billion years. Somewhere above that fuzzy heart, the atoms of the Galileo probe are still circulating. It was never wreckage on a surface. There is no surface. It melted, vaporized, and dissolved, and the planet folded it in like kneaded dough. We did not just visit this world. Instead, a small part of humanity became it. Above you hangs a moon wrapped entirely in ice. Beneath that shell in the dark, there is an ocean, holding perhaps twice the water of every sea on Earth. Everything you saw on Jupiter pulls on that little moon as it orbits, sealed for 4 billion years. That is where we go next.